why do you need access list, or why do you need to do access list? Security. So without access list, everything is permitted in and throughout your network. So the routers does not deny or yeah, they don't block any traffic. So they're going to allow everything in and out of your network. So we need now to bring in accesses now so that we can do what we can filter. And as the name suggests that ACL simple means is a list of permit and deny statements that are used to do what? That are used to identify the traffic, then apply the necessary action as it's deemed to be right. So the first thing that accessors do is first we need to identify the traffic, and we identify the traffic based on the information that is on the IP header. We identify the traffic based on what? We identify the traffic based on what is on the IP header. And after we identify that traffic, now we can apply the right filters, or we can apply the permit or the deny actions. So there are two types of access list. There is layer 2 access list and there is layer 3 access list. Layer 2 access list, they are configured on the switches, and mostly they're going to do ARP and also do what we call the VLAN access list. Then layer 3 access list, these are the ones now we talk about here, about the IP packet that they are configured on the routers, and they filter based on the source and the destination IP addresses. Okay, so access lists, they're configured and they're going to be used for different purposes. So configuration of the access list is one thing. Then where do you apply the accesses now matters. So before you start in the process of configuring access list, you need to know where do you want to implement the access list. Okay, where do you want to implement the access list, or what is the use of the access list? So accesses can be used for the VPN, they can be used for NAT, like when we were talking about NATing just the other day, we used an access list. Access list also, they can be used for filtering of the routing information that is there. So access lists are created globally, and then they're what? Access lists, they're created globally, then they're applied on the place where they're supposed to take place. Now, when you're configuring access lists, always remember, we need to identify the traffic. And once we identify the traffic, we create a list of statements. And the most specific statement should always be on the top, and the most general statement should always be at the bottom. Okay. Now, when we are doing the matching, we always do the match from the top down. And immediately that we get a match, we don't continue consulting the other statements. So accessory is not like a routing where we have to find for the best match. We just find a single match, and once we get a match, then we take the action based on that statement, what it says. At the end of every access list, there's an ACL that we don't configure that is called access list deny all, or what we call implicit deny all. So that statement, it's not seen. So whatever is not permitted will always be denied. Okay, so always make sure that anytime that you have your network, always make sure that you have at least one permit statement. Because what is not permitted, if you don't have any statement to permit, it will deny everything else. And that's what of the problems that people get with access list. One of the problems that guys get with access list is they just do deny, and they expect that everything it will be permitted. No. Nothing is permitted. Immediately that you say access list is, everything else gets to be denied. Okay. Then with access list, we use the wildcard mask. And the wildcard mask, we have three types of wildcard masks. We have the wildcard mask of 0, that is the off bits. We have the wildcard mask of the on bits, that is 1. Then we have the wildcard mask of range. So that is the other type of wildcard mask that we have. So we have 3. The wildcard mask of 0, which means match. So the off bit means what? If you use a off bit, means that the corresponding bit of the octet will be matched. Then if it's an on bit, means it's don't match. Then range is whereby you want to deal with a couple of IP addresses. I remember when we just the other, I don't know, let me not assume that you are the ones that I told you this. Let me bring in a whiteboard. Okay, and let's talk about this. So for me, what I normally do, what I normally tell people with the ACLs, the access, the wildcard mask is just the opposite of the subnet mask. The ACL is what? The wildcard mask is opposite, just bears the difference from what? Just has the difference from the subnet mask. because with the summary mask, if you have a summary mask of 255.255.255.0, if you have such kind of a white mask of 255.255.255.0, if this was 10.10.10.0, what you're going to find that this means the first octet should be 10, the second octet should be 10, the third octet should be 10, while the fourth octet should be 0. That's normally what it means. Because with the summary mask, the on bit means match, that is the network bit, while the off bit is not the off bit is the OS bit, which can be anything. Now with the wildcard mask, it's now the opposite, whereby if you have 0, 0 means match, and where you have 1, that is the on bits, it means don't match. So in short form says ignore the value that is on that octet. So for example, if I put 10.10.10.0 and I put a wildcard mask of 255.255.255, then I put a wildcard mask of 0.0.0.255. This means the first 3 octets, they should be exactly values that are on their corresponding octets. So this should be 10.10.10. Okay. Then because the fourth octet is 255, now this means what can be anything, can be any IP address. So that's the things that you need. So sometimes you find that you have a network like this. Okay. This is 10.10.10.0/25, and this is 10.10.10.128/25. So based on subnetting, these are 2 different subnets. Okay, so let's say now you want to configure a rule that you only want to capture the first octet of 10.10.0, the first network of 10.10.0. Okay, so that means I want only to deal with the 10.10.10.0.1 all the way to 126. Those are the IPs that I want to include in my access list. So if you go with a wildcard mask of 0, that means you have to do 126 statements. If you go with a wildcard mask of 255, it means it's going to include what, both the two subnets. So in this case, we can do 10.10.10.0, then you do 0.0.0. Now, can we do the 126 as one statement? Yes. So what you need to ask yourself, what is the summary mask of /25? And the summary mask of /25 is 255.255.255.128. So in that case, the wildcard mask that I can use is, you can always take 25. I normally say that take the subnet mask minus the mask. Just take 256 minus the mask. It will give you the range. So in this case, it will be 255 minus 128, which will give you 127. Okay, so you can have now wildcard mask range of 10.10.0.001, 127. And now with that, it becomes easier for you to do it. It becomes easier. So because now it's what? It has been, you have given a couple of IP addresses. Okay, because most of the time you find that you might have a scenario where you don't need only one, but you need a couple of, you need to allow a couple of IPs. You need to allow a couple of IP addresses to be included. So now the wildcard mask of range becomes the best one to be used. Okay, so the most important part is just to get the statements, then get the wildcard mask how do you want to do it. So like in this example here, we have subnet mask of, we have 172.30.16.0.254.24 through 172.30.31.0. So as you can see on the third octet, we are ranging from 16 all the way to 31. Okay, so the first question that we're going to ask ourselves, what subnet mask can we use? What mask can we use to do it? What mask can we use to bind together or to aggregate .16 all the way to .31? And this case, you find it's what? Okay. This case now you find those are like 15. They are like 15 IPs. So this, instead of you doing the 16, 17, 18 all the way to 31 as one, you can get one common. You can get the subnet mask that will give you the range of 15. Then now you get the wildcard mask. And in this case, the wildcard mask is what? Is 0.0.15. Okay, so that's there where you can specify the number of IPs that you need to be included. Now, when you give the wildcard mask of range, what the routers do, they do what? What the router will do is going to calculate and convert those values into what? Into binaries. And when they convert it into the binary, when they convert it into the binary, they will be able to tell what? When they convert it into binary, when they convert it into binary, it will be possible now for the router now to specify what to go, which to understand, to get which IPs are matching, that request that you need, the ones that will match the request that you have. So those are the things that you need to get with a subnet mask. Always make sure that you get your subnet mask well. Make sure that you get the wildcard mask well. That is the only challenge that people get, where they don't know how to get the wildcard mask. Once you get the wildcard mask, the rest becomes straightforward. It's just nest. Okay. So with the wildcard mask, when you're doing the access list, there's you can always use the 0. If you have a wildcard mask, a situation whereby you want to deal with a single IP address, where you're dealing with only one IP address, you can use the 000. So you're going to have a situation whereby the all 32 bits, you're going to have a situation whereby all the 32 bits will be off bits. Now, if the all 32 bits are off bits, instead of you writing the 00, you can just start with the keyword host. Now, the keyword host only works for what? Only works for a single host, and only works for extended access list. For example, here when we have 172.30.16.29, you can just say permit host 172.30.16.29. If you're going to have a standard whereby you're going to use a wildcard mask of 255, that is all 32 bits will be off bits. All the 32 bits will be off bits. Then you can use what? You can just simply do the keyword any. You can use the keyword any to make your work to be easy. To make the work to be easy. Now, the types of access lists that we have are two. We have access list that deals with the standard access list. Then we have the extended access list. Now, with the standard access list, it filters based on the source. Only permits or denies the traffic based on the source. So for it doesn't care where you're going. Okay, it doesn't care where you're going. The only thing that is going to check on the IP packet is what is the source of the traffic, or where is the traffic being generated from. Now, with this case, we use the standard access list when we want to deny everything. Okay, so like in this case, you say ACL access list 10 deny 10.10.10.1. So when you say deny 10.10.10.1, in short form, what it's going to mean is the 10.10.10.1 will be denied access to everything. Okay, because you have just said what? I only said that I want to match the source. While with the extended access list now, it filters both the source, destination, the protocol, and the IP addresses. Remember, I told you about what we look at in the IP packet. So on the IP packet, we always look for what? On the IP packet, we look for the source, DST, destination, protocol. We look for protocol, and then we look for the port number. The port number. Now, when we talk about the protocols here, we are talking about TCP, IP, UDP, okay, etc. Okay, so that's what we look at. What? So with the standard access list, out of the 4 criteria, we only check for the source address. With the extended access list, you're going to check for both source, destination, and the protocol in use and the port numbers that are there. So extended access list, it's better to use extended access list when you want to define both the source and the destination. So for example, you might have a situation like this, like my pen now starts behaving. You might have a situation like this. This is a router, okay? So here we have a network. We have 8.8.8.8, and we have 4.2.2.2. So then here, inside here, we have PCs here. So what will we do if we want to allow this PC A1 to access 8.8.8, but not to 2.2.2? In that case, we cannot do what? We cannot use the standard access list. Now, sometimes you find that you want to allow users to go to a server, but only access maybe the emails or access only the web, and they should not have access to something else. So extended access list now will come and help you. The standard access list cannot work. Now, access lists are defined or they are identified by use of numbers, and the numbers that you can use is 1 to 99 for the standard. So when you say access list 9, access list 1, any value between 1 and 99, then the router knows that is a standard access list, and it's only going to expect you to provide the source address. When you put the when you put the extended access list, and you say you have to say access list 100 a value to 189, that's known is an extended. Or alternatively, we can use the named access list. Alternatively, we can use the named SL. Now, as I said, access lists are configured globally, but they have to be applied on the interface. So when the packet arrives on the interface checks and asks, is there an access list that has been applied on this interface? Okay, if there's an interface, if there's an IP address that has been, if there's an ACL that has been applied on the interface, if there's an IP address that has been applied on the, if there's an access list that has been applied on the interface, then it's going to consult the access list statements and apply that, apply the decisions as per, or apply the filter as per the access list. Now, with the, if the access list that is applied on the interface is a standard access list, then the router will only consult the source address. It's going to ask, where does the traffic come from? So it doesn't care where the traffic is, it's going. Okay, a good example of access list is this access list 1. So that in that case means is a standard access list, and then permit, that is the destination. So the command syntax is always access list, the number, then the action plus the source, then the source. So when you say access list 1 permit 172.16.0.0, now what will determine what will be allowed here is the wildcard mask. Okay, and the wildcard mask there says 0.0255255. And in that case, the first 2 octets, because it's 00 means it should be exactly be 172.16. The third and the fourth octet is 255. That means there can be any value. So when you use 255 means ignore the value that is on the corresponding octet. Now, for standard access list, you can configure without specifying the wildcard mask. Okay, when you configure access list, when you configure extended standard access list, you can have a situation where you're going to configure an access list and don't provide the wildcard mask. If you don't provide the wildcard mask on a standard access list, the router will append the 000. So make sure that anytime that you configure an extended access, a standard access list, if it's a multiple IP addresses, always specify the wildcard mask. If it's a single IP address, you can do away without the wildcard mask. Okay. Now, because in this case we have only done access list 1 permit 172.16.0.0, any other traffic will be denied because the router will include another one that says deny any, an invisible statement that you can't see. There's another statement that is invisible that you don't see. Anytime that you create a new access list, you just put a statement access list this. The router does what? Appends a statement that says deny everything. Now that is the implicit deny. So always make sure that for your access list you have at least a permit statement. Okay. When you use the command show ACLs, or when we say use the command show access list, the access list will display to you the access. It will display to you the access list that has been configured. And if the access list has been hit, or there's a traffic that has been matched, or it has been processed through filters based on this access list, then it's going to add what? It's going to show you the match. It's going to show you the number of hits that access list was applied. Now, the other thing that I needed to mention here, when you do show access list, because I don't know if we have one that has many statements, when you say show access list like this one, you're going to realize that these two, okay, let me use this example of the extended before I go back, because there are two. You're going to find that your access list is 101, but your statements, they've been given the number 20 and 30, 20, 10, 20, 30, like that. Huh? Every time that you configure access list, each statement is given a sequence number of 10. So the first statement that you type on the access list will have a sequence number of 10. The second statement will have a sequence number of 20. The second statement will have a sequence number of 30. And the reason why that is done is so that when you want to edit the access list, because any new statement that you put on the access list will always go down, will always be the last statement. My statement here is access list permit 172.16 this. So if I come and had another statement here, let's say I had another statement here, access hyphen list, for example, one, because they're all going to have that, permit 10.10. The network is, yeah, let me say like 10.10. Let me use like this. Let's say I want to deny an IP address, deny 172.16.1.1. So what do you think will happen? Now, when I put this command, access list one deny this, when I go to the show access list, the two statements, this first statement will have a sequence number of 20, 10. The second statement will have a sequence number of 20. Now, in this case, I want to deny 172.16.1.1 while I permit everything on this network. So this order of this statement as they are, this order as it is, nothing will work. The 172.16.1.1 will not be denied. Why? Because everything, the 172.16.1.1 matches the first statement. So if you give me this requirement and I need to place the access list one deny 172.16.1.1 to be on top of the permit statement, then I have to play around with what? I'll need to play around with, because the only option that is there is to delete the access list, then create a fresh with the right order, or I can edit the access list and specify the sequence number for the new access list that I'm creating. For the new access list that I'm creating, so I can put an order that will be on above. Okay. When you say no access list one, it deletes the entire, all the statements that are attached to that access list. So always be careful with that. If you want to delete a single statement within the access list, you have to type the entire statement. Though when you say no access list one, deletes the entire access list. Now with the extended access list, we look for what? On the IP header, the router checks for both the source and the destination address, the protocol, then the port number. But the source, destination, protocol, and the port number. So it checks on 4 things. So the protocol, because sometimes when you want to deny TCP, you want to deny TCP, but you don't want to deny the entire TCP. You only want to deny specific parts of TCP. For example, you want to deny TCP on port 443, or you want to deny TCP on port 80, or you want to deny TCP on port 256. So what will happen? Now, in that case, instead of saying access list this deny from the source to the destination, then you put only TCP, you can put what? You can put the port number, that is the service number. Okay, so like in this case, we have access list 101 deny TCP. So the protocol that is being denied is TCP. The source is 172.16.4.0. The entire subnet of 172.16.4.0. The wide mask is 0000255. Then the destination is 172.16.3.0, 00255 EQ21. Now, if you did this command and you only ended it here, you did add this. If, for example, if you don't add the EQ21, that means you're going to deny the entire TCP connection between 172.16.4.x going to 172.3.x. But now, because we wanted only to be specific on what should be denied on the TCP, that's why we said what? EQ21. So when you say EQ21, that means is FTP. Okay. Now, what happens for those who don't know the port numbers? Okay, you want to deny TCP, you want to deny HTTP, or you want to deny FTP, but you don't know the port number. If you don't know the port number, you can use what? You can use, if you don't know the port number, you can use, what? In that case, you can use, you can use the word FTP. You can just say EQ FTP. You can use the word EQ FTP. So in that case, now it will work. You can use the word FTP instead of using that. Then now they have added the other command of access list 101 permit IP any. Now the permit IP any is just to override the implicit deny all. So they have denied only the only thing that they wanted to deny was 172.16.4 dot going to 172.16.3 dot, while everything else is what? It's permitted. While everything else is permitted. So that's what will happen. Okay. So you see now when you say show access list, The deny statement comes with the sequence number 10, then the permit statement comes with the sequence number 20. So now the order is, it's right. Okay, so let's look on a couple of other things. As I said, when you're creating access list, the access list is created globally, but it has to be applied somewhere. The access list is created, but it needs to be what? The access list needs to be applied. And when you apply the access list, it's applied on the interfaces, on the router interface in two directions. There's in and there's out. There's in and there's out. So in means what? In means is inbound, and out means is outbound. Now, the traffic that is going into the router interface, whatever is going into the router interface is an inbound traffic. Whatever goes into the router is an inbound traffic. Whatever that leaves the router interface is an outbound traffic. So that is also another place that people make mistakes. When they apply the access list, they apply in the wrong direction. So first ask yourself, where is the traffic being sourced from? Is it coming into the interface or is it going out of the router? So for example, for the traffic coming from PC1 and PC2, when you apply it on this interface, when you apply the access list here, that will be inbound. And when you apply on this other interface that connects to the ISP, that now becomes outbound. Now that's when it will become an outbound. So you need to get the right direction so that now it works fine. So what comes first? If you apply the access list in the inbound, the access list will be applied even before route lookups. The access list will be applied even before, be applied even before the route lookups. Yeah? If you apply the access list, when you apply the access list on the outbound interface, then the router first will go in, the traffic will get into the router. The router is going to check on the routes, determine the egress, or that is the outbound interface. And then when the traffic is going out of the interface, it checks what? Is there an ACL or there's no ACL? If there's an access list, then the traffic is filtered based on the ACL statements. If there's no access list, then it does what? If there's no access list, then it will just be permitted without any filters. The traffic will be filtered without any filters. Okay. So to apply the access list, you go to the interface, you say IP access group, then you refer to the access list number, then you put in or out. Now, something else that you need to know, that is this is written here as important. Only one ACL per protocol, per direction, and per interface is allowed. So that means if you configure access list, if I come here and say IP access group to in, okay, so now this interface cannot have two access lists that face the same direction. So when you say access group 2 in, it replaces, the access list already is 2. When you come tomorrow and say access list 3 in, then it will do what? It will replace the existing access list. But two access lists on different directions, they can coexist on the same router. So if I come here and say IP access group 3 out, now that one is okay. The two statements can do what? The two statements can coexist on the same route, on the same interface. But if it's in the same direction, it cannot be there. Okay, it cannot be there. The same thing when you're doing NAT, you cannot, on the NAT, you cannot refer to two access lists. You only have to refer to a single ACL. Okay, so let's see what we need to achieve here. In this case, we want to deny internet access for a specific host, that is 10.1.1.101, allow all other LAN hosts to access the internet. So the question here is, are we going to do standard access list or are we going to do extended? So here we choose to go with the standard. And when you choose to go to the, or if you decide to go with the standard, that means 10.1.1.1, because it's denied, will not access anything past the router. Will not access anything past the router. So we say access list 1 deny host 10.1.1.1, then access list 1 permit 10.1.1.0. Now the reason why he did this, he denied the 10.1.1, which is the specific. Then he permitted 10.1.1.0, which is the entire network. So the traffic coming from 10.10.100 will not match the first statement because the first statement is 101, but it will now match the second statement. Now, with this case, whatever that does not match 10.1.1.x will be denied by the implicit deny. So for him, he didn't want, in this case, we did not want to use access list one permit any, because if you do that, permit any means what? We are going to permit all other traffic, but it's always good that now you be as specific as possible. Be as specific as what? Be as specific as possible. Be as specific as possible. Try to be as specific as what? Try to be as specific as possible. Try be as specific as possible in your filters. Don't be too lenient. Don't be too what? Don't be too open, or don't leave so many things being allowed to go to the internet, because tomorrow you might have guys who you don't want them to go to the internet. Okay. Then now we went to the interface. Yes, someone asked me a quiz. Can you ask the question? Waiting for the question. Okay, Abby use IP range on the access list. Yes, you can use IP. You can use a range of IP addresses, and when you use the IP, if you want to use more than one IP address, you can use the wildcard mask of range. Okay, so for example, if you come here and say, for example, here you add the access list. Let's say we put access list 1, then we say deny 10.1.1.1, then 0.0.0.10. So what does it mean? So in this case, because I've used the access, I've used the wildcard mask of 10.10 0.0.10, that means that I've put a range of 10 IP addresses as from .1. So in this case, you're not going to write it the way that people do, that you're going to write 10.1.1.1 space 10.10.10.10. No, you're going to use the wildcard mask to specify the range of IP addresses that you want to include in what? In your filter. You're going to use the wildcard mask to specify what you want to be included in what? In the subnet mask. Okay. Then after you create your account, you just go to the, after you create the access list, you go to the interface G0/1 and use the command IP access group 1 out, or based on the direction. So it's here, there was supposed to be, there are 2 points that we can apply the ACL. We can do it on the G0/0, or we can do it on G0/1. When you apply it on G0/0, the action will be in, but when you apply it on G0/1, the action will be out. Now, the best practice for the standard access list is to apply it near the source as possible. The best practice for extended access list is to do what? Is to apply it as near the source as, near the destination as possible. Okay, to apply it as much as many as possible, apply it near the destination as possible. Okay, so that's what will happen. So that's what we do. Okay, you want to do between, I mean, for example, you want to do let me get your as I said, if you want to do more than one IP, if you want to do a single IP address, like in this case, you want to include permit range, no, you can't use the keyword range on your statements. The only thing that you can do is to have the access list. The only thing that you can do is to have the ACL. What you can do is to have the ACL now. In this case, because you want to do one to do 1 to 100, then you're going to add this as 100. So you're going to do what? You're going to do access list 1, deny 10.10.10.1.1.1.000 So when the worker mask is 100, the router will know that it's supposed to include 100 IP addresses as from .1. Okay, but you can't use the keyword range. It doesn't allow that. It doesn't allow you to use what? To use the word range. It doesn't allow that. Yes, we can't use the word range. We can't use the keyword range. You have to use the worker mask, and then the worker mask you put a couple of IPs. Okay, so that's what happens. Now you see, now in this case, if you wanted to use, instead of using the worker, instead of doing what? Instead of doing the standard, you can decide now to use the extended. And the extended, you're going to use access list 101, deny IP. So you have to specify the protocol, the source, then the destination. Now, anytime that you see someone using the word any, anytime that you see someone using the keyword any, it means that it was supposed to use a welcome mask of 255.255.255.255, all bits as on bits. Okay, if everything is on bits. So you can use what? You can use the keyword as any. So in that case, now everything works fine. Alternative is, instead of using if you're using what? If you're using the extended access list, if you're using extended access list, you can use what? You can use what? You can use the extended access. You can configure the access list by use of the named access list, where you can say IP access list standard, then you give it a name. Now, after you do that, you're going to enter into the access list mode. You're going to enter into the access list mode. And when you enter into the ACL mode, now you don't need to keep on using the word IP access list, access list 1, access list 2. No, you just do it within that the statement. So like there you can see we have what? We have the access list, we have IP access list, standard, subnet only. So our name is subnet only, and we have already specified that is a standard. Then now we say permit 10.1.1.000.255. So now you can see that now becomes easier for you to do the configurations. Okay. Now, when you're going to apply the access list on the interface, you refer now to the name. Now, one thing that I've realized with one thing that is there with the Cisco, not that I've realized, but one thing that is there with the Cisco is Cisco, they have a problem with what? They have naming problems. Subnet underscore only, and the only is capital. It's different from subnet only when the only is small letters. Okay, so you need to be very careful with that. When you are putting the names with the Cisco, their names, they are totally different. Public, upper capital and lowercase and uppercase, those are two different names. Okay. Now, as I was telling you previously, that what happens if tomorrow you want to have a scenario whereby you say the access list says permit 10.1.1.0.000.255. Then tomorrow there's a requirement that you want 10.1.1.255 to be denied. If you put that statement as the second statement, will always go down under the first one that is permitted. So in this case, you can use the sequence number. Okay, you see this guy was sequence number 10. So this other one, when you're creating this, you put what sequence number 5. Now when you do sequence number 5, now you are specified which position you want it to be. And now when you say show access list, now it's on top of the permit statements. It's on top of the permit statement. Okay. I think there's a question that how do we use EQ or greater? So let's look on this example here. Here we have an example of IP access list extended permit TCP 10.1.1.0.0 any EQ 80. So EQ means what? Equals to 80. Equals to 80. So if you want, you can put not equal to 80, or you can say greater than 80, or you can say less than 80. Okay. Now when you say EQ 80 means it should be exactly, it should be TCP, but only port 80. If it's not port 80, it will not be included. If you put the word not equal 80, that means what? You want to pick anything else other than port 80. So can play around with the greater or the less than, and the both will be all will work. All of them will work. Okay. Permit this, then you can do EQ. So like here we are saying EQ 80, EQ 443. Then now we apply the access list there. Now when you put 80 is the same as doing WW. When you're doing 443, it will be HTTPS. Now everything else now it's going to work. So there's a lab there that we're going to do for SEL. There's a lab that we're going to do for configuring the standard access list. Okay, and the extended access list, then now we can go about it. Now the next thing that I wanted to look at is how do we do filtering? How do we do filter for the traffic that is going into the interface, into the firewall? Sorry, not the firewall, but into the router, so that now we can control the amount of packets that are being received by the router. Because we have something that is called denial of service. And the denial of service is whereby a user does what? An attacker sends a lot of traffic to the router, and hence he consumes all the resources. It consumes the CPU and also consumes the memory. So in that case, we need to do what? We need to do the rate limiting. We want to configure the rate limiting. With the accesses, most of the time, accesses, they just to deny the traffic. Is either to deny or permit. No, what has been permitted into the CPU, it needs now to be what? To be limited amount of packets that they are being received. So control plane policing, the CPP, permits or deny access to the control plane. Okay, so you can configure accesses for the routing, you can configure for the management interface, and also we can configure what we call the rate limiting access to the control plane. So more manageable than interfaces, interface or infrastructure SEL, because when you apply access list for the CPU becomes a lot of work. So the first thing that we're going to do is we're going to create a class map. The class map, now we're going to match the condition. We're going now to choose what actions to be applied to the class map that is based on the policy map. And then the service policy now is to apply the actions that we have specified. So as you can see here, with the class map, first we're going to create an access list that defines what traffic needs to be, what traffic is of it's of interest. We're going to apply that and put which traffic it's of interest to our network. So here we want to do access list permit UDP, SNMP. We want to permit WW and 443 and 222. Now this is the traffic that is designated to the router. Okay. Then we get a class map that say class map COP class. Then we say match access group 100. So now in this case, the class map here is what? We are matching the whatever we have, the filters that we have specified using the access list. Then after that, now we create now the policy where we apply the actions. So our actions is what? Policy map. So we created the policy map. Then we say the class. We put the, now when you say class COP class, it's what you are referencing to what has been allowed, or then what has been allowed by what? By the access list 100. Remember, first we created an SCL, then attached to the class map. Then from that, now we configure our policy. So we say policy, this conform action, transmit, exceed action drop. So if it's transits 30,300 connections per second, then you do what? You drop that packet. Okay. So you see now for the class default, the class default is for whatever doesn't match the first class. We say what the policy rate is 50 packets per second. The allowed packets per second is 50 packets per second. So if it's more than 50 packets per second, what do? The traffic will be what? Will be denied. So we create the policy, the class map, then the policy, then we configure the action. So for example, if you want to define the what do we call? If you want to configure and specify the number of concurrent sections to the router, you can use it by use of what? You can use that by use of you can use what? What do we call this? You can use the class maps. You can use the class maps to protect that, to protect the info that that you have. Okay, then now we go to the control plane and we do service policy input. That means it's for the incoming, so that now it's allowed. Now control panel, this is an interface in the router that manages the I remember we talked about management plane, control plane, and we also talked about what? We talked about the data plane. So control plane is an interface that allows the routing and the traffic to and from the router. Okay, so do you see now when you say show access list, it shows you the number of times that it matched. The letter remitting has been done based on this SCL, so that now you can do that. You can do show class maps, then you'll be able to see the class map if it's working or if it's not working. Okay, the actions of the policy map and the ETC. So you can always see those infos that are there.
Morning.
Morning, Gaston.
Is there access list where it can play a role on QoS management?
The QoS?
Management.
Now, when we do the QoS management, you create first you're going to create the SCL, then you go with the policy map. You go with the class map, then apply it on for the QoS. So the access list, just the work of the access list is to define the traffic of interest. Okay. Then after that, now that's when you do what? That's when you configure the policy map and specify the actions of the letter remitting. So then you can do the class map. You not the class map, but you can do the QoS filters. You can specify the amount of traffic that is allowed and who is given the first priority. So there's no exactly access list that you use, that you configure. The work of access list is just to define what traffic will be matched. Then now you use the access list as a reference point in the QoS policy configuration. Okay, so let's see what next. Okay, so let's talk about network analysis. Let's talk about network analysis that is using network analysis. Okay, so let's talk about using network analysis tools.
Muinde.
Yes.
What about the access list extended? You did not talk about it.
Extended?
Yes.
Extended, we talked about it.
Oh, really? Maybe I missed that part.
Extended is the one that we put the source and the destination. The one that we were doing EQ80, EQWW.
Okay. I see. Thanks. Huh?
Okay, so let's talk about analysis, the network analysis. And with the network analysis here, we are talking about T-shoot. How do we do our troubleshooting? Because troubleshooting is very important. And the first thing is, first you need to know the problem. And the person who reports the problem is the person who is experiencing the problem. So because if you have a problem, I don't know about that problem unless you tell me that there's a problem. So after you tell me that there's a problem is reported, then we go to what? We need to do the diagnostics. And after we do our diagnostics, now we go to what? We now need to get to a solution. So like the analog that is here, someone has said the car has done what? Has stalled. So you do your diagnostics, you realize that the reason why the car has stalled is because it doesn't have fuel. So what is the solution? You need to take it to the petrol station, or you have to send your, these guys that we call them the border guys. They go and come with a bottle full of fuel, then you put it on your car. So those are the things that are there. But when you're doing troubleshooting, the first thing that is there is you need to gather as much information as possible. So when you tell me that you have a problem, I need to know where is your problem, or what is your problem. And for me to get that information, I need to ask you questions, or I need to do some tests to come to do what? To get to know those questions. And that's why you find that when people go to when people go to the hospital, the doctor will ask you so many questions that you'll feel irritated. But what he's trying to do is to get as much information as possible. Then after that, he's going to analyze the information that he has received. Then he's going to do what we call the elimination. Okay. So if someone tells me that I don't have internet access, the first question that they're going to ask that person is, do you have access to the network? Okay. Can you access the servers? That is the question that I'll ask. If he says, yes, I can access the server, then I know the problem is not internally. So the problem is for him going out. So I know that the user has an IP address. So that's why he can access other resources in the network. So I now start doing the elimination. So I tell them, can you ping? Yes. Can you ping an IP address? No. Can you ping an IP address? Yes. Can you ping FQDN? No. Then now I know what is there. So after you do the elimination, now you do what? You propose an hypothesis. Hypothesis is the possible solution. Then now you need to test it. And then lastly, something that has not been given here is you need to document your problem. So the first thing for every good solution is define the problem. So you gather a lot of, for you to define the problem, you need to do what? You need to gather the information that is there, analyze the information that you're getting, eliminate the possible potential causes, then propose a solution, test it, see if it works. If it works, then now you do what? You document it so that if tomorrow it happens, you don't have any much problem to do. So like in this case, a user reports that the internet is not working. Okay, so from the user computer, you access the website the user is trying to reach, the cisco.com, to verify the problem. So when a user tells you that he has a problem, sometimes you need to do it. You need to test to understand if it's really a problem that is there or it's a problem that is not there. Because sometimes people will raise an alarm for problems that are not there. Okay, so gather the information. You are able to access the cisco.com successful from a different computer. So that now means is what? Means now that is an isolated case. If from a different machine I can access cisco.com, but from your machine I cannot access cisco.com, that means what? Means the problem is only within your machine. It's not on with the other people. It means that the problem is only with that single user and not with everyone else in the network. So what next after that? The next thing that is there is you verify that the user computer has its wireless adapter turned on, so you can ping the default gateways, ping to the internal servers, is this successful? Ping to the public address, is this successful? Or public address will be your public IP address. Is this successful or it's not successful? So if those pings are successful, then now you can do what? You can now narrow down and know what is the problem. You are not able to access any internet sites by the name. So you can do NS lookup, and when you do NS lookup, now it will tell you what. When you do NS lookup, when you do the NS, you use the NS lookup to determine the name resolution of the files, so that now you know if it's DNS or it's not DNS. Then from there now you go straight. So most of the problem that we have, we need to spend time in what? We need to spend time in information gathering. Once we gather as much information, then now we know things are good. So see now in this case, we say when you do NS lookup www.cisco.com, it shows you that the DNS server is unknown, so it doesn't respond, and the address that is used is 209.165.202.5. So you need to confirm with the other guys, is that the right DNS? Okay. Then from the information that you have, you just realize, oh, okay, the DNS is supposed to be .6 and not .5. So now you can go ahead and change that information. So you have eliminated the problem now. Okay, you check whether the user computer is manually configured with the incorrect DNS, or is it getting the IPs from a DHCP server? Because sometimes might be the DHCP server is misconfigured. So in that case, now you get the guys who are configuring the DHCP, then now they can change that IP address. Okay, you manually configure the DNS address that is stated in the current documentation test. If it works now, then you can do what? You can go ahead and change the settings from the DHCP server. You can go ahead and implement the changes from what? From the DHCP. Go ahead and change, apply the changes from the DHCP server, because now you have realized the problem is what? The problem is the DHCP server. Okay, is the DNS and not the DHCP. Problem is the DNS. That's why it's not working. So then from there now you have confirmed everything now is working. You document, save the settings, then document your issues. The other problem that guys we get is overutilization of processes, or the overutilization of the CPU. So you can use the command show process CPU. Then it's going to show you the utilization of the different resources that are there for the CPU. Then you can know what is eating a lot of your CPU. Okay, so anytime that you find that there's a certain service that is taking a lot of your CPU, then just know that is what? Just know that there's a problem with what? Just know that service might be under attack. So there's something that is fishy that is taking place. Now you take the necessary action. Show memory, we show you the utilized memory and what memory is free. Okay, so you can see that the used and available memory. You can use the command show interfaces. Now this is a common interface. Shows you if the line protocol is up, the line protocol is not up. The other thing that gives people added time is MTU, mostly with the VPN. With the OSPF, OSPF does not work if both sides have what? They have difference in. If both sides have a difference in MTU size. If both ends have a difference in MTU size, then in this case you need what? You need to make sure that you change the MTU to be the same. The other thing that is there is the duplex mismatch is also another thing that gives people a lot of issues. If one side is using a half duplex and the other side is using a full duplex, there will be what? There will be a problem. If one side is using a full duplex while the other is using half duplex, there will be a mismatch in duplex. So you need to change that. Okay. And if there's a duplex, if there's a duplex problems, anytime that there's a duplex problem, you're always going to find what we call under the collisions. You're going to find that there's a lot of packets there on the collisions. If you find that there's a lot of packets in the collision, then you know it's what there's a problem there. Now you need to allow that, or there's a lot of packets in the queue. You need now to sort it out. Okay, so do you see that here we have the packets, how much packets have been dropped? Like here you see collisions. Collisions should never be more than 0. Okay, should always be 0. If you find that the collisions they are more, then you know that there's a problem with the collisions. You know that there's a problem with the collisions there. Okay, show controllers, you can see what is moving. Show platform, again will show you the backplane that is configured, the serial numbers, the IDEA versions, just to get down to manage to see what is happening. Show interface brief, we all normally know what is the work of show interface brief. Check if there is an IP address, if the interface is up or the interface is not up, and if the line protocol is up. So the first part here of the status is the physical interface status. Then the second part is the line protocol, and the line protocol defines if there's a connectivity between the two ends. It defines if there's connectivity between the two ends or there's no connectivity. Okay, you can use the command show IP interface brief exclude pipe exclude down. So when you say exclude down means what? You want to just do show IP interface brief, but you want the output only to turn up for the interfaces that are up. Those who are down, you don't want them to appear there. So you can also always do the filters. The same thing with the IP route. You can always do show IP route include, show IP route. You can say show IP route include 10.10. So that means what? It's going to display all the IP routes that they have something to do with 10.10 something. So that's just to do the filters that are there. The other command that is there is always show running config. When we say show running config pipe, there are options of doing begin. Begin means when we say show running config begin line VTY, it's going to do a show run and it's going to display the output as from the line VTY. Anything that was come before the line VTY will not be displayed. The same thing you can say show running configs. There's a difference between show running configs route section and show running config include. When you say show running config pipe include, and for example, you put the word router, it's only going to show you which lines have the keyword router. But when you say show running config section router, it's going to show you the output of the section router. So the configs and the words that have what, and the sections that have the word router. So you can do that to make sure that your show run experience is very friendly. Okay, then we have those other things there. Again, you can do that's the character, the regular expressions. Okay, so like you see there, you can say show interface gigabit 0/0 include. Then we put the upper, which matches the character at the beginning. Then we put giga. So now what will happen? Errors, then packets. So you can see all that. So that means that it's when, okay, with these filters, is whereby you want to be very specific on the output that you want to get. Okay, you don't want to get unnecessary traffics. So that's what happens. Now those ones will play around with them so that you come to understand what it is. So what I wanted to do, ping. What is the work of ping? Ping is just to do what? Ping is supposed to give you, if the test is successful for connectivity, yeah? And when you're doing ping, there are a couple of ping results that might come up. There's success means it's okay. When you get timeout, timeout means that the request was sent, but you're not receiving any reply. The request was sent successful, but you didn't get a reply. When you get unreachable, destination network unreachable, it means that your problem is to do with routing. There is a problem with what? That means there's a problem with routing. that means there is a problem with there's a problem with what? With the routing. So you need to check on the routing. That means there's a problem with with the routing. That means there's a problem with the routing, and you need to check on your routing. Then trace route is always the same. Trace route, okay. The difference between ping and trace route is trace route shows you op by op. Trace route shows you op by op, and then with the trace route shows you the TTL, and the TTL decrements from that. The TTL now needs to keep, when we do this with a TL of 1 in the IP header and the destination of ports of this, the packets are out. The packets now can be seen that they're being sent or they're not being received. So that's it. So the only thing that I wanted here to talk about is the IP SLA, okay? And the work of the Cisco IP SLA, which is a very important concept that is introduced, is to verify the, what do we do? To give you what? To identify where there are problems in connectivity, or yeah, to give the availability, or you have a guarantee assurance of measurements. So with the IP SLA, there are a couple of IP SLAs that we got there. We can do one for latency, we can do one for packet loss, we can do one for network jitters. Now, sometimes you find that you have multiple service providers, but one service provider, when you do the ping goes through, or when you do the trace route, it goes through, but guys are complaining that there's a lot of, the network is very slow. So in this case, you can use IP SLA, and you decide what you want to monitor, okay? Now, when you're doing this, there's always going to be the IP SLA source, and there's IP SLA responder, okay? Now, who is the responder? An IP SLA responder is the one that replies with the measurements that are being measured, a response to the measurement that is being measured. Okay, so the IP SLA can be used for the availability, for the network performance monitoring, for voice monitoring, the SLA monitoring, network monitoring, etc. And we have the different protocols that are given there. They have the jitters, the FTP, etc. So now, the mostly one that people use with the IP SLA is the TCP echo. The most that people use is what they call it, the TCP echo. But the TCP also echo only does what? It only monitors when you send the probe, the device that now responds, you just with the TCP echo, you only check availability. Is the device that you are monitoring available, or the device that or what you are monitoring is not available? So that's what you check. But you can do the others to check. Now, the reason why people are using the TCP echo, why most people use the TCP echo, is because the TCP echo does not need a responder. It just needs a device that can respond. It just needs what? Just needs something that can respond. So you need now to do what? In that case now, you don't need to have the responder. But when you have the responder, when you need to do the jitters, when you do the packet loss, you need to have a device on the other end. You need to have a device on the other end that is capable of doing what? Of responding with all the information that guys have requested for. Okay, so we have the IP SLA source, and then we have the IP SLA responder. So Cisco devices, they can act as IP responders. They can be configured for the IP SLA responders to act as an IP SLA responder. Okay, so we're going to see how to do that configurations. The other thing that is there is for you to do the span. Okay, the port mirroring. The port mirroring is whereby you want to do a packet capture and forward the packets to the sniffer device. A device that is running, for example, things like packet filters, packet sniffers, like for example, is Wireshark. Okay, so we always, when you're doing the span, when you're configuring the span on the Cisco switch, you need to define which interfaces that will be the pairing of the interfaces that you want to capture the traffic, and then you replicate it to the span device and send it to the span device. Okay, so like here we have what? We have the sniffer device that is connected on port 3. So we want to monitor the traffic that is coming from PC1 going to PC2. So our source interface becomes G0/1, and the destination interface becomes what, G0/2 for the traffic match that is being monitored. Then now we are going to send the traffic to what? To the G0/3. So that the traffic is being sent. So we have the local span. So like there, we create what? Monitor section 1, section monitor section 1. Then we say source interface G0/1. Okay, so we're going to capture the packets that are originated from G0/1. Then we say monitor section 1 destination interface G0/2. Now the destination interface is the interface where we have the packet sniffer. Okay, where we have a packet sniffer, and we can have as many packet monitor sections as you wish to have. You can have as many packet sections as you want to do the capture for the interfaces that you want to capture the traffic. Show monitor shows you where the traffic has been monitored, the configurations there, the cancellations, and the traffic is there. Now, the question that people ask is, can I do a span or a section monitor while the sniffer device is not on the same switch as the device that is being monitored? Can you do a span when the two switches, whereby the device, the interfaces that you want to capture the traffic, they are not on the same switch as where the sniffer is connected. That means that the source interface and the destination interface, they are not on the same device. Yes, you can do that. And that you do what? You do what we call the remote span. And with remote span, you need to configure local and remote VLANs. You need to configure local and remote VLAN, because now the span will be done through the VLAN. So as you can see here, on switch 1, we want to capture traffic coming from what? The target PC, which is connected on G01. And then the sniffer is connected on switch 2 on G0/2. So we need to configure on both switches. So on switch 1, we're going to create the span VLAN, okay? And we're going to create a VLAN called VLAN 100. Then we put the name. We have to tell it that is a remote span. Remote span means what? It's going to act as a span device. Then we're going to say source monitor section 2, source interface G0/1. But the destination interface, we are going to use the remote VLAN 100. We're going to use the keyword remote VLAN 100. Then we go to switch 2. Okay. When we go to switch 2, we're going to create again VLAN 100 and use the name remote span. Then we say monitor section 3, destination interface G0/2. But the source interface now will be the VLAN 100. The source of the capture will be VLAN 100. Okay, then now from that, now it works. Find that now it works. So it's possible. You can do local span or you can do the remote span. Then the rest is just going to be working. Okay. ER span is whereby you want to the encapsulated remote switch port analyzer. ER span is for traffic that is going through what layer 3 device, where you have IPs. So in this case, you're not going to use the interfaces, but you're going to use what? You're going to use an IP address. You're going to use an IP address mostly when you want to do filter the span between what? Two switches that are connected behind a layer 3 device. So that's one I will not go deeper into it. It's part of the self-study, so you can take time and do your study for that. Okay, give me a minute. Give me 2 minutes. Okay, let's talk about now implementing network services. Implementing the different network services that we have. And the first service that we're going to talk about is NTP, understanding network time protocol. And the reason why we need NTP is to have synchronized clock or a time between our network devices. So what you find when you talk about the logs, when you talk about certificates, logins, they have to be verified. The validity needs to be identified or needs to be validated. When you get the security logs, you need to be able to tell that when really did it take place. So that for your network to have a synchronized time, whereby all your devices have the same clock, then NTP comes in to help you. Okay. NTP comes in now to help you because you need it. What NTP will do is will allow users to do what? Will allow now that the devices to get time from the NTP server. So with the Cisco, it allows you to use any of the Cisco devices as an NTP server. It allows you to use one of the Cisco devices as an NTP server, while others get time from there. Alternative, you can configure a server. You can get your NTP server, or you can use the cloud-based and configure your devices to get time from that NTP server. Okay, so you can have multiple NTPs and into your network, and you can do the synchronization. You need to choose which one is more secure, okay, or which one is the which one will be what? The master. You need to choose which one is the master. Now, so that the clients cannot get time from any NTP server, or they don't accept any NTP traffic that is coming through, you need to create authentication. You need to configure passwords between the clients. And that is to say what? NTP authentication key. Then you can have as many keys as you want. So if you have multiple NTPs, they can be using different passwords. So say NTP authentication key 1, MD5, my password. So my password now is your password. Then you say NTP authenticate, NTP trusted key is key 1. So which key do you want to trust? Okay. So in case even someone comes and creates other NTPs, other authentications, it will not be trusted. Then now you go to the, so on the server, you just create the password and you create the trust. Then you go now to the client and you say NTP key. Make sure that the client also has the same key as what? As the server. So you say NTP authentication key 1, MD5, NTP authentication, then trusted key is 1. Now the command to connect an NTP client to NTP server is address of the server. So when you say NTP server 10.0.1.22, it's going to connect without the password or without sharing the password. So when you add the 10.0.1.22 key 1, you are telling the NTP client that now you're going to do NTP, and your NTP will do what? You're going to do NTP, and your NTP will be based or will use, when you say the NTP packets, include, okay, include what? Include the key as specified on the NTP, and that key is what? And that key is key 1. And what is the key 1? Key 1 is, it has a password that is my password, just for security reasons. Then again, if you want to be specific on which networks will connect to the NTP server, you can configure access list to filter the IPs. So in this case, on core 1, we have said access list 1 permit 10.1.1.15, which is the host. Then we said NTP access group 1, access group IP access group peer 1. That does it mean? It means that it's going to allow NTP access from traffic from 10.1.0.15. Okay. Then configure with the only specified IP addresses. Then now we have another one for if you want to do a specific network. Also, you can do that. You can create an IP access group 1 permit 10.1.0 NTP access group. So when you apply the access list, can be 2. You can do it on server only. That when you say server only means that I am an NTP client and I can only answer synchronization requests from the network of. I'm the NTP server, and I'm only going to allow NTP synchronization from the network of 10.1.0.0/16. So now in that case, you're limiting who can have access to the network. The other things that are there is the logging services. And the logging services we're going to talk about is syslog, netflow, and SNMP. Now, syslog is about getting the logs. Netflow is about just getting a flow, mostly when you want to get the bandwidths, utilizations, etc. So let's look at the understanding the syslog. The syslog messages can be done into two places. They can be console. Console is the one that we get when you configure the file, like the router. Like yesterday when we were doing the router, we were getting what? We were getting those messages, BGP notification, BGP what? Now that is a syslog message that is on the console. You can get the syslog message when you're on through telnet by using the command terminal monitor. You can use what we call the terminal monitor. You can create the syslog messages to be sent to the flash, or you can do it on the buffer memory. Now the problem with all these three is if the router restarts or the switch restarts, you're going to lose the logs. And the storage cannot be infinite because it's limited. So in that case, we can configure our syslog our routers to communicate with a third-party syslog device. But before you see how to do that, the syslog message looks like this: sequence number timestamp. So the syslog message will always going to have timestamp is always going to have the severity index. Severity index means how critical is it, and we have eight levels, and that is level 0 to level 7. Okay, emergence, alert, critical, error, warning, notification, information. Now, when you configure, like an example of this, it's April 22, 10:05. That is the time. That tells you it's line protocol. Then in the middle there's 5. Now that 5 is the severity level, which means it's notification. Then shows you now the message is line protocol on interface. This is status. It's up. Okay. Now from that message, now we can tell what is happening into our network. Okay, now how do we configure syslog? To configure syslog, you go to the router and use the command host trap, host trap, and then you choose which level you want. Now, when we read the levels, it's not a must that you have to, you don't need to do one at a time. You just choose the highest level that you want to enable the trap. So for example, if you want to enable the trap as level 7, when you enable trap 7, it's going to allow all through from 7 to 0. It's going to allow from 0 to 7. Now, according to Cisco, 0 is a higher severity, or it's more critical than 7. And 2, when you're doing the trap, don't configure 7. Don't enable 7. Only do up to 6. The maximum one that you're allowed to do is up to 6. 7, we use it for critical. We use it for debugging. And debugging is very resource intensive to see real-time logs, and it's very resource intensive. And with that, if we go with it, what will happen? If we go with the syslog, when you go with the debugging and you leave it working, like running for long, it's going to do what? It's going to bring issues in your. It might even cause your router to hang. Might even cause your router to hang. So please don't leave it working for long. Then the last one is understanding the SNMP. The beauty with the SNMP now, it gives you what we call the graphical output of what you want to see. So it's more friendly. And also with this is we need to have the managers, and then we need to have the managed devices, the agents. So the agent is the managed network device. That is your switch or the router. Now the beauty with the SNMP, it runs both on the network devices plus on our PCs. So it gives you a full picture of what is running on your network. It gives you a full picture of what is running on the network. So it works in two things. So the manager communicates or gets the information from the database for the managed agent, the MPI, then gets that information, contains the traps that you need. Then now it can do what it can get the information that you're there. Then it correlates it into a graphical information. Now, SNMP is divided into three, version 1, version 2, version 3. Version 1 and 2, they connect based on the community strings, while version 3 will now provide authentication, integrity, authorization, and access control. So version 3 is more secure than what? Than the previous versions. It's more secure than the previous versions. Okay. Then we have another one that is called the net flow. The net flow now is just about, it's a collector where it collects all the information that you have, and it can help you. So net flow, it's more like a billing, something like a bill, because it's going to tell you how much traffic has passed through the interface inbound and the outbound. So it just helps you to get to see what is happening into your network from each IP. So collect that information, shows you that, okay, this is what has been going on from this interface. These packets that came in went out from this IP address. These are the packets that were sent back and forth, so that now you'll be able to understand what is happening into a network. So if there are spikes, you can be able to tell what caused the spark and which devices had that problem. Okay, so you can see like this one. Now the analysis of the net flow looks like this. As I send the data now, you can choose which information that you need. Okay, so go to the router, then you'll be able to tell the packets that are being exchanged from one router to another router, because it allows you to see a lot of info that you need. So see like this now, the cache shows you this, the row that was used, how many packets that were sent, how many bits were shared from the specific IP addresses and the destinations. So now at least you can have an idea of what people are connecting to and how much data are they downloading or uploading to specific IP addresses. So go deeper into it. Okay, so where can NetFlow be implemented on the network? It can be implemented on the outbound, the router that connects you to the outside world, so that you can tell what is connecting in and out of your network. So we have the NetFlow applications that you can use. So you're going to play around with it and see how it gives out that information, and you'll be able now to get all the good info that you need. Okay, so then what you need to do is, first you need to configure the NetFlow. You need to define what needs to be captured. Okay, the IP flow export is the command. Then you choose the versions. There are different versions. Then IP flow export destination. Now destination is the server. Destination, we say IP flow export destination 172.16.10.2. 10.2 is the server that is running the NetFlow application. The server that is running the NetFlow application. Then 99 is the port number that will be used. Then from there, now you just go to the interface and you specify the NetFlow that will be captured. Is it for the inbound or for the outbound traffic? And that's it. The traffic now will be sent to the routers. You'll be able to see all that info that you need, all the information that is. So when we say show IP cache flow, so you can see the cache, the exporter that was there, shows you the packets, the source, the destinations, how many packets were sent and how many packets were received. So you can see all that info. Okay, so it's very good. It's a very good protocol that people use to do it, to just analyze their network, analyze the network usage, and also gives you all the timestamps and everything. So there's a lab for that. So when you do that lab now, we'll be able to go deeper into it and explain a couple of things that are there. So then we have, the last, we have what we call the event manager. The event manager is just something that has been introduced by Cisco so that we can do what? We can configure how do we respond to events. How do we do what? How do we respond to the events? So the event manager is more about the basic iOS scripting. So where you configure script that if this takes place, then take this action. If there's this instance, if there's an instance that has taken place, then what action should be taken, so that now what? We respond to the problem, so that we can respond to the issue that is there, and it's embedded into the system. So I'll urge you guys, you'll take time to read about the EEM, the event manager, so that you go deeper into it and understand how it works, so that at least you can do a basic scripting. But for you to do it, you need to have some basic ground, some background in in scripting. Yeah, you need to have some background in scripting, so that you understand how it works. Okay, so I think I'm only left with one more topic, then I'll be letting you guys do the labs. And that topic we'll be talking about is access control, implementing secure access control. Then after that, you'll be able to, there's a lab that we were supposed to do for wireless. We do it then you'll do all the other labs. But also remember there are what? After that, there are a couple of topics that are self-study, though some of them I have covered them, but take time to read the other self-study materials. And then again, today, you'll remind me to share with you new logins for the lab. I need to share with you guys new logins for the lab so that you'll be able to access the labs beyond tomorrow. Not beyond tomorrow, but beyond today, so that you can be able to access the labs beyond today. Okay, so I think we can have a tea break. Okay, guys, so let's look on yes, Akilo ask. Go ahead and ask. Okay, Cisco Prime is a Cisco product, or it's a Cisco solution that is used to be able to monitor and also manage the Cisco different devices that we have, or the different solutions that are there. So Cisco Prime is just, it's a product on its own that Cisco uses that now incorporates all this other stuff here. So instead of having an SNMP server, you can host the SNMP server on the Cisco Prime. Okay, the net flows can be used as the Cisco Prime can be used as the net flow server, and also can be used to give everything, the information that you need. So as I said, Cisco Prime is able to support, you can configure the access points, you can configure the routers, you can configure the switches, and all Cisco devices plus third-party devices. So it's a management. So Cisco Prime is a management, while SNMP, NetFlow, and SEME, they're only monitoring tools. SNMP is for monitoring, does not do any configurations. The same thing with the NetFlow. Then the CME is just about correlation of, they call it the correlation for forensic analysis of the logs that you have. So that is the key thing. Cisco Prime is a different product on its own. Okay, so let's talk about secure access. Secure access, and in this case here is about how do we allow guys to connect into the network in a secure way. Now, this is for management, not for the users. It's for management, not for the users, for management. The secure access is for management. Okay, how do you allow management access into your network? How do you allow management access into the network devices? How do you allow management access to the networks? So that's what we are going to look at. How do we access the routers and the switches we use? Telnet, SSH, HTTP, and HTTPS. Now, Telnet and HTTP, they are not secure. So most of the time we don't recommend, or we don't advise people to go with Telnet and HTTP. So if it's possible, use HTTP and use HTTPS and SSH to connect to the router through the line VTY. Or if you have direct connection to the router, you can use the serial cables. You can use the serial cables to do the management. So there are a couple of passwords that needs to be configured. There's the blind secure, there's the enable secret, and there's the enable password. Now, the difference between anytime that you configure a password and the password has the word enable password or enable secret, when you put secret, means the password will be encrypted. While you use the word enable password, just like that, without the word enable secret, it means the password will not be encrypted, so it will be in plain text. So nowadays, you're going to find that most people, when they configure the logins, we are using what? We are using more of the line. We are using more of what? We are using more of the secret word, the keyword being the secret, than the what? Than the password, because secret is more secure than what? It's more secure than it will be encrypted than like with the password. Okay, so configure that. Then alternative is, instead of using just the passwords, instead of just using the passwords alone, you can configure it. You can configure to use the passwords. You can decide to use username and password. So let's see, how do you enable which algorithm will be used for encryption. So for enable secret, you need to choose which encryption is there. So you can use SHA-256, you can use MD5, or can use the secure script. So the default one that is used for encryption is always the MD5. So when you say enable password, when you use the word enable password Cisco, without changing the algorithm, then it will do the MD5. It will do the MD5. So you can see there now we have, when you just put the enable secret without changing the encryption algorithm, there'll be a problem. So that's what you see here. Now we had to what? We had to say enable algorithm type as, you choose which one you want. So the SHA-256 is more secure than MD5. SHA-256 is more secure then MD5. Okay, so you can use that. So when you say enable secret, so the two options, you can say enable secret or you can say enable password to configure the enable password. And the enable password is used to secure the privilege mode. It's used to secure the privilege mode, that when people are moving from enable password, when people move from enable password, they don't do it. When people are moving from the enable password, they don't get they can't access the enable password without they can't enable the privilege mode without a password, so they have to have a password. They need to have a password so that we can communicate to. Okay, so that is for that. Then line console passwords. These are passwords that are used to protect the console for the users who are connected to the console. So you say line console 0, password Cisco, then the word login. So when you put the word login, means you're going to be prompted for the password when you connect through the console. If you don't put the word login, if you just put line console 0, password Cisco, and you don't put the word login, okay, the router will not prompt you for authentication. So you'll not be required to put the password. So you have to put the keyword login. Then there's a executive timeout. Executive timeout now is the period that the console section will be, if it's idle before it gets timed out. So that is 5 minutes, 0 seconds, 5 minutes, 0 seconds. So it means that within every 5, if you open the line console and you do nothing within the first 5 minutes, then it will go into time out and you have to be required to do it to provide your login as again. Now, when you do that, when you put the hard password, when you say show IP, show run, you're going to see now the password will be seen. The password is in plain text. Now, the reason why that is a problem is if you log in to your router and you didn't want me to know your password and I do show run, I'll be able to see your passwords. So in that case, so that you can encrypt the passwords as they're being saved or being displayed on the running configuration, you can use the command service password encryption. Service password encryption encrypts all the present and future passwords in the router, so they are not displayed as plain text passwords. Okay. Then the other alternative to use is, instead of using just the normal passwords whereby people share the same password, you can use the username and passwords. So you can say the username these. Then when you create the usernames, you can always provide the privileges levels. Okay. And then also you can choose what algorithm you want to be used to for the user traffic for the password encryption. So you see, like here we are saying username. Username is tier 1. Then we said secret. Now the reason why we are using the word secret and we don't want to use the name password, because when you use the keyword secret, the password is what? It's automatically encrypted. The password is automatically encrypted. Okay, but if you had said service password of an encryption, also the password one also will be encrypted. So remember, the main thing is which encryption mode do you want to use to encrypt your passwords. So now you have to choose that. Though it's not a must to change the encryption. If you use the word secret, you're always going to use the MD5. Though MD5 is not a good, it's not a strong encryption protocol. Okay. So device hardening options is you can configure security password minimum length. So in this case, now we just want to do the what we call it. We want to do the hardening or the complicity of the password. So you can say security password mean length. You can say complicity levels. Okay. Then you can say transport input. For the line VTY, we prefer to go with the SSH than to go with the telnet. Okay. So you can change to SSH. When you say transport input SSH, it disables the telnet. Then login block for these attempts. So again, you can configure if someone tries to log into your router a couple of times through SSH and the login has failed. The login has failed, then you can do it. You can configure what will happen. So login block for this time. So you can say if you try 2-3 times, it fails, then we're going to do it. We are going to block you for this period of time so that you will not be able to log in. So login quiet mode, access name before access as permitted also to ensure that. So again, you can configure the users that will be allowed to log in into the network. Okay, so you can configure the access list and where they're allowed. Another alternative, you can configure what we call AAA. AAA is authenticate, authorize, then account. So authenticate tell us who you are. Account, what are you allowed to, authorization is what are you allowed to access into the network. then accounting, what did you do? So we need to get the reports. Okay, so you can do that. So if you don't include the, if you don't integrate your router with a third-party AA servers, like a radio server, you can only do authentication and authorization on the router. So you don't get accounting. So if you want to get accounting, you have to go to a third-party server. You have to go to a third-party server, and this is now becomes, it's scalable, it's it's flexible. Okay. Then AA servers, most of them, there are two types. There's standard based, which is one which is Cisco based, and also you can use the proprietary one, which are open for everyone. So when you're using authentication, like what we talked yesterday when talking about wireless, you can configure. You can also configure to use the certificates. Authentication is the process of verifying a user before they are given network access. It can be based on the credentials, can be based on the certificates, and also can be based on the biometrics. And the biometrics now, mostly for the networks, we don't use biometrics most of the time. We only use the certificate and the credentials that the user knows. Okay, so we choose which one you want to use. So radius server versus Taka server. Okay, the difference between the two is radius server, it combines authentication and authorization as one process, while Taka server, each of them is identified as what? As a separate process. It's identified as a separate process. So with the Takas, you first need to do what? Log in, provide your authentication, get authenticated. Then anytime that you request to access a command, that's when it does what? It queries the Taka server to see if the cat command is allowed or is not allowed. Okay, but with the Radius server, both of them are what? They are combined into one. So Radius and Taka server, the AA protocols. So Takas was for so long was Cisco proprietary, while Radius is an open authentication server. It's open to, that can be used now to protect your network, both for the users who are accessing the network and for the device access to the CLI. Okay, so this slide gives you the difference between the two. Okay, developer, Takas was Cisco, Radius was Livingston Enterprises, but nowadays Radius has become now an industry. It's an industry protocol. It's an industry. Protocols that are used is the port 81, 1812, and 1813. Though some books you're going to find that they are still using the 1612 and 1613. You might find some books that will tell you that Radius uses what? 1612 and 1312. So initially that's where they started, but when it became an open, they changed what? The port numbers were changed to 1812 and 1813. And remember, Radius is UDP, while Takas is a TCP port 49. So that is another main problem, main difference between the two. So combines authentication, authorization into one process, which means now the only process that is done separated is the accounting, while with the Takas server uses the AA model and separates the three services. So you authenticate, then that's what we apply. We kick in now the authorization. At authorization, now we kick in what? We bring in now the accounting part of it. So that's the main differences between the two. Now, the other problem is with the Radius, it encrypts only the passwords packet, while with the Takas, encrypts the entire packet body. The entire packet that is moving from the authenticator to the Takas server, from the authenticator to the Takas server, so everything is encrypted. Now, Radius server allows you to allow network access, but Takas does not allow network access. So Takas was only designed for admin. Takas was only designed for what? Takas was designed for administration, was designed to manage admin access into the devices, admin access into the network. So I think this one we looked at it yesterday, where we said it's access request, then we get an access challenge. Then after you answer the challenge, now you do what? There's access accept and there's access failure or access reject. When you get access reject, means what? It has failed. Your password is not right. So you need now to check it, and you report it again. The same thing with the Takas. As I said, Takas separates the three processes. So the first thing, you start the authentication, so you request to be authenticated, and what this guy will send is a get user, And when get user means now the router or the client needs to provide the username and passwords. Then after it provides the username and password, now the attacker server will respond with either accept or reject. So you need to know the packets here. When you're using the Radius server, it's access challenge. One is access request, access challenge, access accept, access reject. While with attackers, they just use what? They just use the keyword accept, or they just use, they don't send access request, but they say get user. The command that is sent from the attacker server to the client is, the attacker's client is get user. And then now you can do pass, okay, to continue, and then the packets will be accept and reject. So in the exam, they might want to ask you which of the following packets are for, or responses can be what you can get them from attackers, or which one can you get from Radius. Okay. So then now from there, it's just a new model, and about the a new model, the username and admin. Then you use the command AA authentication login, AA authentication login. Then you say group, default group Radius local. Now, when you're doing, even if you have a Radius server or a attacker server, it's always recommended that you maintain the local as a backup. It once happened to me that I configured a router, and I enabled AAA, and I had integrated well with. I thought that I'd integrated well with the router, with the attacker server, or with the authentication server. Then I disabled the local users, so I didn't have any local user. And just to realize that the router timed out, we had saved and then everything timed out, so we had to log in again to change 1, 2, 3, and that's the time that we realized that our configurations between the router and the authentication server, they are not configured well. There's a problem, and there's no way that we could retrieve even the key that we could reconnect back the Radius. And now your guess, it's as good as mine. It was a lot of work for us because we had now to start to see how we can bypass the passwords. Okay, that was the first thing. So luckily in that one, I could bypass the password. Then the other one, I did it on a firewall, and that firewall by that did not have bypass. So I had to reset the entire firewall and start afresh. So always make sure that you maintain at least one local account that will be used in case that we can't communicate with the servers. So we have Radius server. To add the Radius server, you just say Radius server. Then you say address IPv4 or IPv6. Then you put the port number, the IP address, followed by the authentication port numbers. So the authentication port numbers by default is 1812 and 1813. Those guys, you might find that they're using different port numbers because of security reasons. So sometimes we don't want to maintain the defaults. You find that sometimes we don't want to maintain the defaults, so we need to change the port number. So still that one is okay. Then you put the key secret. Now the key secret is used between the attackers, the Radius client and the Radius server to authenticate themselves. Between the Radius client and the Radius server to authenticate themselves. So that key also needs to match between the two sides. Then now, from there now you say a group server, you create a group, Radius server group, then the server name, you could, the server name now we call it what? We have called it Radius server. Then we say AA authentication login, server auth, okay, Radius followed by the local. So that now we have created the group. Now on the group, you need to add what? In the group, we had to, you see on this group, we said server name, Radius server. So we only need to create a group, mostly, so we, instead of creating multiple, we just create a group and we had our servers there on the group. So then from there now it works fine. So now you see when you go to the login authentication, instead of saying login authentication local to refer to the local logins, the local login server, we use what login auth to refer to the Radius server that we used. Then from there, it's okay. Now the beauty with going with the Radius or the attacker server is when you have multiple network devices, they can only use the same. We can use a single device to do what? We can use a single device to the user accounts are defined on the attackers. So all those network devices will do what? Will use the same logins. So again, to add attackers, we do attacker server You give it a name, then IP address this, IP address IPv4, then key again is the same. So it's just all the same. The configurations are the same. So the only thing that you need is, are you going to just need to know is, are you using Takas or are you using the radius? The rest is just the command syntax are the same to add that. Then from there now you configure the AA authorizations, the AA authentications. Then you choose what? You choose the Takas server. Okay, the AA authorization configs what you need to be allowed to manage the configurations. Now remember we said radius and Takas, they do what? They support the accounting, yeah? They support the accounting, so you can configure also the accounting, so that now your router knows where will they send the logs for the management, so that now you can, from the server, from the Takas server and the radius server, you can be able to know what users are doing. Then now the rest is just straightforward. So you can always go with the local user, or you can configure it. You can create a local user, or you can configure a remote user. You can create a local user on the file, or you can do a remote user. So not on the file, but on the router. On the you can do it on the file. Sorry, on the router or on the switch. Yeah? Too much into firewalls. I think that's everything I'm mentioning is, I remember firewalls.
Muinde, do we have the labs for AAA and Takas?
If I have?
Do we have the labs for? Do you have the labs for AAA and Takas?
AAA, they should be. Yeah, there's a lab. There's a lab for. Yes, there's a lab for. Yes, there's a lab. It's not on the list.
No, I was wondering. Let me check. I just
on the list of the labs that you. Or if you'll finish.
Okay, I see.
There's a new, guys. There's a new. Yeah, there are new logins that I'm going to share with you today. There are new logins that I'm sharing with you guys today for what? For the extended lab period. There's a new logins that I'm sharing with you, so that you can have the logins that you are using will expire today, so you might not be able to log in by end of the day, past 6 p.m. Kenyan time. So I'll be sharing with you guys the new logins that will allow you to access the lab for another 60 days.
Okay.
So let me work on that. Yeah, there's no labs. I understand that all the labs today, you can't finish them today by end of the day.
Muinde, do we still have to use to access the labs at that particular time, or we can access it 24/7?
The new one, I think, the new one is not limited to time. The new one is not limited to the hours. The new access ones that are the extended one, they don't limit the times.
Perfect. So means I can do it midnight when I'm free at my side.
Yeah, you should be able to do it. Yeah, you should be able to do it anytime.
Okay.
Okay, so guys, let's do labs. Let's do labs. Let's do labs.
Muinde, are you there?
Cedric?
Yes.
Mm-hmm.
I was wondering.
Mm-hmm.
I think today is our last day, right?
Yeah.
So maybe will you talk about how we can prepare with the exam, and maybe if there is some simulation tool we can use to prepare the exam, things like that. Are you going to share maybe those information?
There's the dumps that I'll be sharing with you guys before the end of the day. Then for simulation, mostly guys, we use for simulation mostly I use if you want to play around with it to do more labs, we normally use either Packet Tracer or GNS3. Okay, you have reminded me. You had requested me guys for the what do we call it? For the images, for the RS. So let me work on it so that I can share with you guys the RS for the GMT.
There's no any like an exam that we can maybe an exam simulation, like the way you do searching, like just to prepare for the
okay, the dumps that I'll give you will be PDF based. What is happening nowadays is the simulation that we used to do was called, there are two that we can use. There's the VCE for simulation, and there's another one called Prepway. There's another one called Prepway. Unfortunately, of late, I think I've tried to be getting cracks. Nowadays, I don't get a crack. And so it means now you have to buy a subscription. You have to subscribe for the software. So for us, we do have, I think for me, I only have one account. I purchased for only one account. So I don't know how that one goes on. So unless if you are ready to spend some few dollars to buy a subscription for maybe a month as you prepare for the exam. But now for me, I'm able to download it, and using the subscription, I can convert that into PDF. Then I'll share with you guys the PDF.
Okay.
So I'm working on that. So I think I'll share everything with you guys before the end of the day.
Okay.
Then also doesn't mean that our relationship ends today. So before you do the exam, you can always check with me if there's anything new that can help you guys pass the exam. Because I don't know how soon you are planning to do the exams. Next month, end of the month.
It will depend. We need first to do some exercises just to make sure that we are ready.
Yeah, so I can give you the dumps today. Then maybe if you are doing it next month, maybe mid of April, 1 week or 2 weeks before the exam date, you can write me an email. I see if I have latest dumps, if there are any dumps that will have come up by then.
Okay.
I think we whatever we review, we can also review do it at the same time we are reviewing the dump, so that to take the latest dump, it will be easy for us instead of having only only like 1 week of only dump. We better start to exercise, since now we are also reviewing other subject or self-study, some other part. then we concentrate on the last before like 1 week.
Okay, I'm saying the reason why I'm saying that a week or two you let me know is because the dumps keep on changing. Yeah. You might find, you might find that the dump that I give you today, by the time end of April, you might find that there are like 5 questions that have changed.
Exactly is what I mean. Instead of before, I mean when I'm planning like doing exam like end of this month, I think it's better to start having the current we do have. Then when I'm going to concentrate only on exam, I do see those changes. It will be easy for me to cram it very easy instead of to cram it very easy instead of just doing it at the same time I'm going to do exam. So when I'm doing the self-studies, review, whatever, I also do it at the same time with the current you already have.
Yeah, that's what I'm saying. Today I'm going to give you the ones that I have. Okay. So then also they can guide you when you're doing the study, because you can always be going through the questions. You see there's this concept that I haven't gotten. You go back to the notes, you verify. So you do both. You study as you also check on the dams. Then before you do the exams, now we can see what we can do.
Okay.
Yeah. So the best thing, guys, is as much as they are dams, don't say that now because they are dams I'm not going to study. Dams are not 100%. You are not sure if they are going to be correct or they are not correct. Sometimes you find that they're 100%. Sometimes you find that they are not. They are 99%. Sometimes you might find that it's 80%. It depends with how if Cisco have changed their questions, because they keep on changing the questions. So the best thing is first take time, study, and then do the dams. Now the dams will help you in case you go to the exam and there are 2-3 questions that are different. Then you'll do what? You'll be able also to answer them. For now, I think CCNP doesn't have any labs for now, but I think because I think they had issues with their platform. They wanted to change the exam platform completely. So in the next few months, they might reintroduce the labs in CCNP. So for now, in the exams, there's no. It's only going to be the multiple choices and the drag and drop.
Excuse me. You have told us you will give us some extension regarding the labs.
Yes.
You say, I would like you to suggest how would you, if you were at our place, how would you use it? Because it will not be there indefinitely. How would you use it efficiently if you were at our place?
Okay.
You consider the extension we have and the time we have, the open time we have. How would you use it efficiently?
Okay, so the extension is for 90 days. Okay, the extension is for 90 days or 60 hours. Now, with this one, I think for the one that you are using now, the lab is accessible from 9 a.m. Is it 8 to 6 p.m. But now this other one, because they don't have that limitation of how many hours per day, they will do what? They will give you 60 hours cumulative of your lab time. So you can use it the way that you want. So you can log in, do it. I'm sure if you were to leave it 60 days, that will be around 5 days. 24 hours, 24 hours, those will be like 3-4 consecutive days, which will be enough for you to finish the lab if you are doing consecutive days. Even if you do 8 hours, that will be a good number. So what I normally tell people is, if when you're going to go to study, you have to balance between your work, set apart a time that you're going to be doing the lab. I don't do it because of the lab time, counting, because it's 90 days, but also remember you have the quarter of 60 days, 60 hours. So whichever comes first. So let's say you activate the lab today, it will start counting 90 days from today. Okay, that is after 3 months, it will expire automatically. Then after that, there is the 60 hours. So if you leave your lab running without existing, so you leave it running, your time will be counting. So if you come use 30 minutes from the 60 hours, now you have what? You have 57 hours. You come use 10 hours, your time is coming, it's reducing until it gets to 0. So what I normally tell people is try to set up a time that you can do the lab. So if you decide that's it's between 4 and 6 p.m., you can set that to be the time for you to do the lab, so that when you log in, you don't waste on your credits of the time allocated that you have been allocated. That one will go a long way to help you. So you have to really.
The counter, do you mean like to stop the counter? Is it pause or just log out?
You see when you log out from the lab environment.
Okay.
Yeah, you log out from the lab environment.
So like for example, someone has other task during the day. Maybe I can say maybe the two following hours I am free. I have no task. I'm kind of free. Now I'm going to concentrate. Maybe do 3 or 4 labs. Then I have to log out.
Yes.
So that I cannot, so that I'm not wasting my minutes, my lab minutes.
Yes.
Not pause, but log out.
It doesn't have a part of pause. It only has the log out part.
Okay, it's similar like what we have now. Huh?
Yes, but what we have now, it's limited between 8 to the evening, 8 to 6. So they're not even if you leave the lab on for the entire day, it doesn't count on your time, because it's based on the daytime. The lab is allocated between 8 a.m. to 6 p.m. But now with the one for the 60 hours, it's based on how many minutes have you used. Yeah.
Anyways, I guess we don't have even 90 days before we pass the exam. For us, it will be kind of how to manage the minutes we have.
Yeah.
Thank you.
Does it save what we currently, for example, if I've configured a router and it's in the middle, when I log out and I come back, so does it keeps the configs I had before?
For the extended one, the extended one I need to check, but for the current one, yes, it does save. For the current setup that we are having, because you have been guaranteed a lab at pod, it will save your configs. If we do the extension, I'm sharing with you the logins. If they are login using mine, I see if it shows you the pod is dynamic, like CCNA, they give us dynamic pods, which means the pod that I log in today is not the pod that I'll log in. I might be allocated the next time that I log in. Now, in that case, you have to do the entire lab. Finish the lab before you exist. If you exist, it doesn't save the configs because the what do we call it? The pod that you're going to be assigning will be allocated dynamically.
Okay.
Muinde.
Yes.
I see we did not cover the this Python.
Which one? Python is part of there are modules that are self-study. Let me give you the
It's
modules.
under self-study. Okay.
Yeah. Let me give you the modules that are self-study so that you can remind me if there's any that we have not covered. So self-study, there's Matcast, there's QoS, there's Enterprise Network Security Architecture, there's using Cisco DNA Center, SD Access, SD1 Solution, Python Programming, Network Programmability Protocols, and then we have API in Cisco DNA Center and vManager.
Excuse me. Hello, Muinde.